can just click on the link and start filling up the form. The link is same. So I'll share it again. All right. All right. So let's talk about what exactly is SD-WAN. So in order to understand SD-WAN first we will talk about legacy network. So legacy means old-fashioned, correct? So if you have done CCNA with me, so you must remember something we had discussed during end of the class, correct? We have just got an overview of what is a legacy network, correct? So what is a legacy network? Old-fashioned, like whatever we have been learning so far, whatever you have done in CCNA, whatever you have done in CCNP, okay? So that is all old-fashioned, okay? So when we talk about legacy network, we need to talk about the plane of operation here. We need to talk about the planes of operation, okay? So what do you understand by this term, planes of operation? What comes to your mind when you hear this term, planes of operation? Correct. Correct. So operation means something. Now understand this plane. You can take this as a logical area. Okay. So this is nothing but it's a logical area of operation. Operation means something is happening there. There is some work happening in that particular area. Okay. So if we talk about legacy network, we have primarily 3 planes of operation. So which are they?
Control plane, management, and backup.
Correct. So we have management plane, then we have control plane, then we have data plane. These are the planes of operation. Now understand, planes of operation means something is happening in this planes. Okay. Now what do you understand by management plane? Let's talk about first management plane. So what do you understand by management? Management means what should be happening here?
We are accessing any device for configuration perspective through CLI or GUI.
Correct. Managing. So managing means what? Managing, administrating, basically. Basically, when we talk about managing, it's all about administrating. Okay. So when I say administrating, what comes to your mind? Managing certain devices. So if I'll tell you, okay, go and manage this particular router, what will be your first approach? How will you do it? Yeah, say. What will be your first approach? If I'll tell you, go and, manage this router. So what is the first thing that you will do?
Access the router through
You will need to
console or
access,
CLI.
correct?
Yes.
You have to configure it basically, correct? So management is all about configuration here. You're talking about configuring the device, correct? So first what you will do, if I'll tell you go and manage this devices, the first thing is you will take the access of the device, correct? You have to configure it. So configuration means how will you do the configuration? First, you have to take the access of the device, correct? How will you take the access? Either you have to use a CLI interface or you should get a GUI interface. Once you have the interface, then you can run the command, do the configuration, correct? So then you can manage the device, correct? So CLI access, now how? How will you get the CLI access? How can you get the CLI? Yeah?
Console.
Okay. What else?
SSH.
SSH,
Telnet.
Telnet,
Console.
correct? So you will take an SSH, you will take a telnet, you will take, so basically what your SSH and telnet will do, it will help you to access your device, correct? It will take you to access the device, then you can take access through SSH or telnet so that you can do whatever configuration. Basically, it is giving you a platform to access the device. Okay, so if you talk about management plane, it provides access to your networking device through CLI, through GUI, correct? So we have protocols such as SSH, Telnet, SNMP, HTTP, HTTPS, okay? So with the help of all of this, we can manage our device. So that is all about management, to configure, to take the access of your device, okay? Take the CLI access, take the GUI access, okay? Do Telnet, SSH, okay? Take the access. Now, once you take the access, then what will you do? So if I'll tell you, okay, configure route, configure OSPF, for example. So once you take the access, you will start with the configuration, correct? So once you do the configuration, you will do the configuration, you will save it, okay? So how? What will happen there? So what do you understand by control? Who controls you? Who controls our body?
Brain.
Brain, correct? So you can say control plane is the brain of the device, okay? So it controls the brain. So let's say how it controls. So what your control plane will do is, it will make forwarding decision, okay? So once you have done the configuration over here, your control plane builds the forwarding intelligence. It builds the forwarding intelligence, okay? So forwarding intelligence, how it is building. So understand this, forwarding intelligence means it is giving you how to make the decision. So this is the decision maker, basically. It's a brain, okay? So forwarding intelligence, how it is built. How the forwarding intelligence is built. So if I have to give you an example, it uses all the routing protocol. So with the help of routing protocol, what it will build? If you give a route, say router EIGRP, ASN. So once you give this command, what is built?
Routing
table.
Routing table, correct? So it uses all the routing table, routing protocol to build up the routing table. So what is routing table basically? It's basically telling you how to forward the packet, correct? So that is forwarding intelligence, how to forward, correct? So it uses the routing protocol to build your routing table, right? For EIGRP, everything. Then you have the, what do you call? ARP cache or NDP table. ARP cache. So what is ARP cache? It uses the ARP cache to build the forwarding intelligence, correct? Router uses ARP cache. So what is there in the ARP cache?
MAC IP address, MAC address.
IP to MAC mapping, correct? So routing table, it is built where all this stays. It is part of your control plane. So it is building this intelligent. It will give you IP to MAP mapping. Okay. What is NDP? NDP, sorry. So this is similar to your ARP. Okay. NDP, if you have done IPv6, so you will see this in IPv6. Correct? Is ARP supported in IPv6? Does it support? Why?
No.
No.
So why it doesn't support? Any reason? What is the reason why IPv6 doesn't support ARP? Yes, anyone?
There is no broadcast needed in IPv6.
Very good. Yeah, that is the right answer. ARP request, it's a broadcast, correct? But if you talk about IPv6, IPv6 doesn't support broadcasting. It supports unicast, correct? Anycast and multicasting. So that is why there is no concept of R in IPv6, correct? It builds the neighbor discovery, right? So that is ARP cache, that is part of the control plane, right? Then if you talk about MAC table, so if you talk about switches, we know what is MAC table. So how the MAC table is built? How does switches build the MAC table? Correct. So on basis of what? Source MAC or destination MAC?
Source
So,
MAC.
correct. It uses the source MAC to build the MAC table. So the MAC table is built by the switches, correct? Then STP, it uses STP to define the port roles, correct? Port roles and the states, correct? So if you talk about redundancy, FHRP, RRRP, what it does, all your FHRP protocols, it builds what? Gateway, virtual gateway. It builds the details of virtual gateways. So what is all this? This is all your forwarding intelligence, correct? On the basis of this, your device is deciding how to forward, okay? Then fragmentation. You have fragmentation, encryption, translation. All these are part of your control plane. What is fragmentation? Remember layer 3 header, correct? Fragmentation. So if the packet size, your Ethernet by default, Ethernet technology by default, this is the MTU, correct? So if the data is more than this, it fragments, correct? So how to fragment, all those mechanism is part of your control plane, okay? Encryption, what is encryption? What do you understand by encryption?
Hiding of data.
Correct. Security. So what happens? Converting plain text to a ciphertext to protect the passwords, correct? So encryption is part of control plane. Translation, we know what is translation, NATs, correct? So that is part of control plane. Okay, so this is few examples. Okay, this is not just the only example. This is just a few examples just to give you an idea what happens in the control. So when we say it is the brain, so why is it the brain? Because it is building this forwarding decision table. Mute yourself online. Okay, so this is how your devices build this forwarding intelligence so that they can decide. So in a brief, okay, just to summarize this concept. So I'm taking an example of a router. Okay, so if this is my router, so control plane, okay, so you can say it is the receiving end. It is at the receiving end of the traffic. So when the traffic receives, okay, when it receives the traffic, what should I do with this traffic? That is the forwarding intelligence. Where should I forward? Should I drop this packet? Should I translate this? Okay. Should I convert this? Should I encrypt? Okay. All this decision is part of your control plane. Getting it? Getting the point?
Can you please repeat this once?
Repeat what? This thing? Okay. So let me show you. Which point? I didn't get. Your voice is not clear.
Yeah, last line. I just missed that last line.
This point? So
Yes.
fragmentation, it's the part of your layer 3 header. Okay, so Ethernet technology, mostly this is I'm talking about the MTU, the size of the data. By default, it supports only 1500 bytes, correct? So if the data size is more than 1500 byte, so then it has to be fragmented. Fragmented, you can consider, if you don't know about fragmentation, you can relate this with segmentation that happens at layer 4. Okay, breaking down the data, the huge data into smaller parts for the ease of transfer so that it can be transferred easily. Okay, so that is again part of the control plane. How should I fragment? Okay, and then if you talk about encryption, encryption is nothing but converting the plain text into a ciphertext for the security purpose. Okay, then in translation, NAT. So in order to access internet, the private IP needs to be translated to public. So it creates a NAT table. So that is part of your control plane. So to give you more clarity on this part. So once we do all this control plane, all this configuration on the control plane. So see, so this is, we are talking about CPU over here. Okay, so this, I will elaborate on this point later when we'll talk about why SD-WAN. Okay, so as of now, everything is happening over here. You have built a OSPF. Okay, so OSPF, your routing table, ARP cache, whatever I just spoke about, the control plane, that is all built here in the control plane. So you have the routing table, NAT table, encryption, ARP cache, everything is part of your control plane. Okay, so and this is my data plane at the bottom. Okay, so what is my data plane responsible for? Receiving and forwarding the traffic. Now I've received the intelligence. If you want to make any notes, you let me know. Okay, now I have received this decision. Now I know how to forward, what to do with this data. Okay, whether I can drop or I can forward. Okay, so data plane, this is responsible for receiving, processing, and forwarding. So it's all about traffic, forwarding the user traffics, okay, to and fro of all your traffic. So that is data. It receives the data. Processing means if I receive it, what I should do. Okay, so let's say, for example, so this is my device. So I'm receiving some data over here. Okay, so on the basis of this, the router have a routing table. Routing table on the control plane. Okay, so this is also called as RIB. Routing information base. Okay, then we have something called as FIB. What is FIB?
Forwarding information.
Forwarding information base. Okay, so what exactly is FIB? Now FIB is part of your data plane. Okay, it is part of your data plane. So when I say data plane, FIB, so FIB is nothing but it's a short. Okay, you can, this is the cache. Okay, this is the memory, this is the cache memory. Okay, so this is just a short, you can say, smaller piece of your RIB. Okay, so basically when your data arrives, your FIB is already, this table has built the forwarding intelligence. Okay, and there is a FIB table available. So most of the time your data, when the data comes, okay, so it will check the FIB and it will forward. So the cache is already there. Like, so it is similar to your DNS cache. So if you're a frequent visitor of a particular website, it stores the IP address on the cache memory, correct? So similar. Okay, so this FIB, it will check the FIB and it will forward. Now this is, if this is a special data, for example, this data says, okay, I need to be translated. I need to be encrypted. Okay, I need to be fragmented. So then the router will say, okay, go to your control plane. Okay, go to the control plane, get yourself encrypted, and then I will forward basis on the decision given by my controller. Okay, so there are certain cases when it checks the control plane, but most of the cases it will check fib. Now, if you have done MPLS, you must be aware of LFib. Correct? So it builds a MPLS. MPLS is at which layer? Which layer is MPLS? 2 and 3 both? Like ARP? ARP is at which layer? ARP is at which layer? Okay. 2.5, right. It is 2.5, intermediate, okay? So MPLS is between. It is an intermediate, okay? It's an intermediate layer between layer 2 and layer 3, okay? So data plane, it is responsible for receiving and forwarding the packet. FIB is a part of data plane, okay? So most of your policies. So what happens in your data plane? Policy. You create policies over here. So policies basically means ACLs. ACLs, okay? To forward the packet, to discard the packet, to deny, permit, all those policies is part of your data plane. QoS. What is QoS? Quality of service. So it has 6 categories. What are those categories? Shaping, policing. What else? Congestion avoidance, queuing, correct? All those are part of your QoS. So what is shaping and what is policing? So policing means cutting off the data to avoid congestion. So here you can set up the limit. You can set up the threshold basically. So just to give you an overview. So let's say you have some traffic, for example, video traffic. You have set up the limit that it should be 40%. 40% of my bandwidth, I've given it to my video traffic. Okay. So this is the threshold that you have set up. So if your traffic crosses, so this policing will cut off. It will not allow this traffic. It will cut off at 40%. It will not allow only. Shaping, it will, again, it will restrict at 40%, but it will not cut off this packet. It will keep it. Okay, it will say, okay, wait, I will process you later. This will simply say, no, not at all. Directly, stop. This will say, okay, wait. When the line is clear, there is no congestion, I will process you at a later time. So that is shaping. So all this decision, it is part of your data plane. QoS, policing, okay, all this part of your data plane. So why are we talking so much about this planes? Because if you understand this plane, you will be able to understand the question why SD-WAN. Okay. So if you have understood this, then you will be able to relate why SD-WAN is so much in demand and you know why everyone wants to get into SD-WAN infrastructure. Fine. So now let's talk about the traditional architecture. Okay. So traditional architecture is based on these 3 planes only. Okay. So legacy network or a traditional architecture . So as of now, what we have been doing. So if I'll tell you, I have, 3 branches. One branch in Bangalore, one branch in Chennai, one branch in Hyderabad. Okay. So we have few devices over there, few LAN networks. Okay. We have few switches and we have few PCs, laptops. Okay. So I'll tell you, okay, we need to, set up the devices. Okay. So what you will do, if you are the network administrator, what we have learned so far, we will access this device. Correct? Configure, do all the configuration. You will do routing protocols, you will enable NATing, all the configuration you will do in this device. Correct? And then make the reachability. So everything is working. You will take the switch, you will create VLANs, you will assign the port interface. Fine. Then let's say you have done with Bangalore. Okay, you have set up Bangalore. Now you have to go to Chennai. So maybe you're some colleague. So some colleague who is sitting in Chennai, he will do the same thing. Correct? How much time will it take to set up all this thing? It will take time. You are setting up the entire architecture. So basically what I want to highlight over here is, if we talk about traditional, okay? So if we talk about traditional network here, every network device maintains their own management, control, and data plane. Okay, so what does mean? So this router has its own management plane, control plane, and data plane. You will take the access, you will do the configuration, create the forwarding intelligence, and then on the basis of that, it will forward the data. Similarly, this router has its own. So you have to take access of this, do the configuration. You have to take the access of this, do the configuration. So in a traditional network, you have to take the access of the device individually and configure. Is there any concept wherein you can just, take the access of all the device? So this is my router EIGRP. And if I give this command, automatically all the routers should get this configuration. So in traditional network, we don't have that kind of setup. We simply copy and paste. What we should take the access, copy and paste. Correct? So we cannot do this router EIGRP and let's say I want to push the same. So that is traditional. Every router you have to maintain its own. So basically, there is no centralized device. Centralized mechanism is missing because all this is present in one device itself. Every device has its own management, control, and data plane. Right? So there is no centralized. What do you understand by centralized device? Centralized means there is no mechanism wherein I give this command, router EIGRP, and I can push it to all the device just by accessing this central management. Correct? By sitting over here, I want to access all this device, all the device that is there in my lab. So we don't have, traditional network doesn't allow that. So there is no centralized mechanism. Every device needs to be configured individually. So that is a traditional architecture, what we have been studying so far. Getting the point? Understanding? So this is how your SDN networks is different. And this is why what makes it different. So what is different over here? So in SDN, what we have done is we have removed this part from the devices completely. Okay. So this is my control, forwarding intelligence, everything. This is my brain, right? This is my brain. All the decision regarding my packet is on basis of this brain. What if I, separate this and take it under my control? I take it from the device, okay, this part, and I will take it under my control. And I can do this configuration. So this configuration, I can push it on all the device centrally. So that is what SDN is all about. Now you're be specific. I am using the word SDN. I'm not using SD-WAN. SDN is software defined network. Okay, so what it does, it extract out all the control plane from all the device. So if you talk about traditional network, in traditional network, this two, control plane and forwarding, so data plane, it is also called as forwarding plane. These two are coupled together. Okay, so forwarding plane is nothing without the control plane. If my control plane crashes, this is nothing. How will it get the forwarding intelligence? Okay, so they both are coupled together. If you want to write something, let me know. I will keep on going. Right. Okay. So let's say if my control plane crashes, there is no routing table. How should I forward the table? There is no NATing, no fragmentation happening. So they both work hand in hand. It is coupled together. Now in SDN, what if my management is not coupled together, because even though if you're not able to access the device, so we have options available there. Okay, if SSH doesn't work, if Telnet doesn't work, we can take the physical access of the device. So if this is not working, but still it will not affect these two at a larger extent, correct? But they both have to go hand in hand. If this crashes, what is the use of this? Correct? If there is no forwarding plane only, what is the use of forwarding intelligence? Right? So they both are coupled together. So remember this point. In traditional network, your control plane and data plane are coupled together. Okay? So in SDN, we divorce them. Okay? So we separated the control plane from the forwarding plane. Now the data plane is all the device have. Okay, so data, your devices is left with management and data. So it may have a management plane, it may not have management plane. Okay, so SDN devices only maintain these two, management and data plane. Now SD-WAN is aware it has removed this also. Getting the point? Okay, so what we have done is we have removed all the controlling concept and we have made it centralized in SDN architecture, software defined. Okay, so in software, the control, we have taken it under our control. So from sitting any location, anywhere in the world, you can just take the access. So this is all software based. You can do any configuration just from a single point. So that is the beauty of SDN. Any configuration you can run, you can push the command in 2000, approximately suppose 2000 devices. So with single command, you can push altogether in fraction of seconds, you can push it. So that is SDN. Isn't that great? Sitting centrally, managing all the device centrally. Okay, so SDN, centralized management. So it offers you centralized management. So sitting anywhere in the world, you can access the software and you can build the configuration and you can push all that configuration to your devices. So that is done on the basis of templates. So I don't want to introduce templates at the moment. So we will see. Now SD-WAN, see, if you know already the concept, so then you will understand all these terms, templates and all. Okay, but if you're new, so go step by step. You will understand everything slowly, and because it is not, you will not be able to understand the entire concept so easily. So it has to go. He's smiling because he has already experienced it. So yeah, so you have to take it slowly, understand each and every concept slowly, step by step. Then you will be able to get a clear picture. Okay, so we'll take this. We will do that. We will understand each of the step by step instead of jumping directly into the architecture. So we will understand slowly what is SDN. All right. So SDN, it's an umbrella term. Okay, it's an umbrella term. Software defined network. Okay, so SDN, there are different types. So under SDN, you have SD-WAN, you have SD access, then you have something called as ACI. So WAN, it's all about WAN side network, outside network, public network. Okay, when you're building, when you want to control your WAN side network, so that is when your SD-WAN comes into play. SD access, LAN networks, internal networks. When you want to upgrade to software defined internally, when you want to build up your LAN networks, when you want to upgrade your LAN network through a software defined. So that is what SD access is all about. It's all LAN. ACI is for your data center. Data center. Okay. So Cisco. Now Cisco is a company. Cisco has not developed this. Okay, so if you learn, so if you go to security, so most of our firewall, only ASA is Cisco. Most of the product that you are learning under Cisco, it is acquired. Similarly, software, this SDN, it's not something developed by Cisco. Okay, so if we're talking about company called Viptela and Meraki. Okay, so this too is acquired. This two are the separate. This was a separate entity. Cisco has acquired this company, their software, and now it is called as Cisco Viptela and Cisco Meraki. So Meraki we don't cover. So what we will be learning is we will be learning Viptela. Okay, Meraki is, you can say, not advanced. It is just it just doesn't offer much features as compared to Viptela. Okay. So some companies you might some companies they use Meraki, some companies uses Viptela, and these are the other popular SDN controllers that we have in market currently. So Cisco uses this Viptela, Meraki. So VMware, they have NSX. Okay, then you have WAN, Juniper, have Northstar, Contrail. So these are other vendors, SD-WAN that is currently you will come across. There is one more, Palo Alto has it. Aruba. Aruba is Palo Alto's SD-WAN. Okay. So SD network, it's an umbrella term. Okay. So what is SDN? Understand what is SDN now. So listen to the statement. Yeah, I'm talking about that. No, there is no session for Meraki. There's only Viptela that we cover in NH. Meraki, see, if you understand Viptela, you will be able to easily understand Meraki, or you can upgrade to any of this because the concept is same. So Meraki, it's a kind of, you can say it's a lower version. It doesn't offer much features as compared to Viptela. So Viptela, it covers an exclusive. There are many things in Viptela. Okay, so Meraki is just limited. So if you understand Viptela, you will be able to relate it with Meraki. Meraki, we don't cover it here in NH. But there are Udemy, you can find some good courses, or you have it in YouTube also, many good courses available. So the concept remains same. So if you understand the concepts, so then everything is same. So it's similar. We do routing and switching of Cisco. But if you go to Juniper, it's not something new that you will be learning, right? So the configuration is little different here and there, but still you will be able to relate basically. Okay. Now SDN. So what is SDN? So as I said, it's an umbrella term. Okay. So from this only your SD-WAN. So the concept is based on this only. So listen to the statement now. It's a programmable approach. Okay. That fully controls all behavior of a network from a centralized software called controllers. Okay, bouncer. So let me explain. Okay, so programmable approach means what? What do you understand by the word programmable? Correct? Automating basically. Programming means automating. Okay, so it's an automated process, you can say, to just break down the sentence. It is a programmable approach. It's a software basically, which is completely automated. Okay. Automated for what? to control all the behavior of your device. Okay, whether it's routing, whether it's building policies, whether it's giving any basically control. When I say control, understand the forwarding intelligence. Okay, related with the forwarding intelligence. So it's an automated process to control all the forwarding, to build all the forwarding intelligence from a centralized software. Centralized software means from a single software, which we call it as controllers. Okay, so this controller guides the device on how to. So controller, now if we talk about SD-WAN. So we have 3 controllers over here. So just an introduction, we will talk about this controller in brief tomorrow. So understand what are controllers. So when we talk about SD-WAN, so we have 3 controllers over here. So we have V, manage. V stands for Viptela, okay? V smart. V bond. All these 3 are controllers. All these 3 are controller. Now, when I say controller, controlling means you can take the access of this device, you can do the configuration, and it will push all the configuration. Okay, all this thing. Now, these 3 have their own behavior. So I am not getting into that at the moment. So now this controller, when I use the word centralized, okay, so you can have this controller anywhere. Anywhere means you can have it in your premises, in your office location, has a hardware. You can install it there. You can put it on cloud. Okay, you can use it on the cloud. Basically, you can control it from anywhere. Okay, it can be on premises. You can just outsource it. You can put it on cloud. Okay, so it completely, from there you can access. Okay, before saying using the word cloud, what do you understand by virtualization? Let me ask you this. When I say cloud, okay, when I say virtualization, virtual machines, okay, so we are getting into the era. We are late, in fact, so we are already in the era of virtualization. There are concept of virtual machines, okay? So what do you understand by this virtualizing? Virtual machine. When I say it's a virtual machine, what comes to your mind? What is a virtual machine? Correct. So basically, there is no hardware. It's all software based. Correct. So virtual machines. So as of now, I don't have my Eve installed. So by the way, I got a new laptop. So all my students, they must be aware the trouble I had with my last laptop. Thank you, Ayush. So finally, yeah, I got a new laptop. So nothing is installed at the moment. So yeah, coming back to the point. So otherwise, I would have showed you what is virtualization. So virtualization is nothing but with the hardware. Now everyone uses, most of you all must have used Eve, correct? We all know what is Eve NG. So when I use Eve, we have routers and switches, correct? So is this physically present? Is this the actual hardware? No, it is virtual machine, but it exactly acts as the actual device. Okay, so that is a virtual machine. So it has the same images, copy of your images. Now we also use Windows Server. Correct? We can use a Windows PC, which acts exactly how you install your Windows operating system. Everything remains the same. It's a copy of your hardware. So that is virtual. So basically it is in cloud. Okay, cloud-based. Now you must have heard about SaaS. What is SaaS? Anyone?
Software as a service.
Software as a service, then infrastructure as a service. Okay, so why I'm making you familiar with this term, because then you will be able to relate what is vManage, where it is vManage, so that you can relate it accordingly. Okay, So if you talk about SaaS, software as a service, okay, so the best example I can give you for SaaS is your Netflix. Netflix is a SaaS. SaaS means software as a service. Okay, so Netflix, what it does, it has made you available all the videos. It is using a software, it has made all the videos available to you. Now you can use it anywhere. So initially, okay, so if you go like few years back, how we used to take songs, how we used to take phones. Okay, so we can relate to it. So songs we used to download and keep it in our phones, correct? Do we used to listen to the songs online? No, we couldn't have imagined. We used to download songs, we used to store it in MP3, correct? So that is now advanced. Now it is all online. We have Spotify. So that is the software as a service. Google Drive, software as a service. So everything, storage, it is giving you storage, correct? You can store your device in the cloud. So that is SaaS. Similarly, your virtual machine, it's a device, it's an infrastructure. Let's say, okay, it's an infrastructure that you're building in cloud. Infrastructure, so you must have heard about Azure, AWS, your Amazon cloud. So what you're doing in Amazon cloud, you're building your complete setup, you're building the complete data center in the Amazon cloud. So that is infrastructure. Okay, so that is your VM. So if we talk about this three controller, when I say you can put this on cloud, so you can put it in Azure, you can put it in Amazon cloud, you can put it in Amazon, or you can give it to now there are vendors, other vendors also available who takes care. Now we don't have to. Now what Netflix does, Netflix doesn't have to manage all the for how fast my internet is, what if my internet goes down. It is all cloud based. So wherever it has rented, they take care of everything. So we don't have to worry. So that is, okay, so this is one of the advantage of SDN networks. Okay, so back to the point, what is SDN? So it is giving you a centralized controller. So now I've built my data center in cloud. I can access it anytime from anywhere in the world. I can do the configuration down. Okay, so that is software defined networking. Okay, your controller guides the device how to forward the traffic. Basically, it builds the forwarding intelligence. It calculates the optimal path and pushes the result to the networking device. Okay, so this is all automated. We do not have to do anything. So your SD-WAN, if you talk about SD-WAN, it uses a protocol called as OMP. It uses only one protocol, basically vSmart. Okay, on the basis of this, it calculates the optimal path and it gives the intelligence to the data. So that is why it is faster. Okay, and it interacts, it uses APIs. What are API? APIs, anyone?
Application protocol interfaces.
Correct. Application protocol interface or
Programming interface.
programmable interface. Yeah. So what exactly is API? Programmable interface. So what it does basically? Now APIs, it's an interface which makes two different software to talk to each other. Okay, two different software. You can talk. The best example I can give you for API, which we use every day. If you create any login credential, let's say you want to create Cisco login. So it gives you an option to log in with Google. Correct? So anywhere, if you go to any website now, it gives you an option, login, instead of creating a new credential, rather login from Google only. So once you click on that, your Google account automatically pops up. So it does an API call basically. So it makes two different software to communicate with each other. That is API. Okay. So SD networks uses APIs. This is how they build up, forward the decisions there. Okay. So now it is all about artificial intelligence. Okay. So all the algorithm that it is SDN uses, it is all artificially built. It uses the artificial intelligence, machine learning concepts. just to, good to know knowledge. So that is how it builds. So that is how it is advancing day by day. Okay. So that is SDN, software defined networks. So if you talk about the advantages, so yeah, so it is ease of network administrator. It is the network administrator task. Now we don't have to take access of the device individually and forward all the configuration. We can all do it centrally. Provision networks quickly. As I said, SD-WAN, it is faster. Okay, it builds the forwarding intelligence with the help of OMP, and immediately it is faster. So once we will start the lab, you will be able to relate how it is faster. Okay. Application, it offers application steering. Now this is interesting. What is application steering? Now, if you remember floating static route. Floating static route, we create backups, correct? So now, for example, this is my edge router, okay? And from this end, I am connected to ISP1. And from this interface, I am connected to ISP2, okay? So this offers me a good bandwidth, okay? 100 Mbps speed. This one has only 2 Mbps speed, for example. Okay, so now let's say I have voice traffic as well as data traffic, both. Okay, it is segmented. Now, voice traffic, if you can say voice traffic, it is quite sensitive to delay. Sensitive to delay means it has to forward faster. It requires an higher bandwidth. Sensitive to delay means, now see, students are joining offline, so they are using Zoom. So if they don't receive my voice fast, okay, if the voice is delivered in delay, so will they be able to listen to me? So they will hear something like, okay, we are going to learn. So imagine getting the point. So the voice is sensitive to delay. It has to forward fast. Data, it can go, okay. It will keep on downloading, okay. Still, it can, okay. So for this, I want this traffic to go from this traffic to go from this here, okay. So SD-WAN offers steering. So it automatically identifies, okay, it's a voice traffic. It will automatically push it towards the faster link, and it will automatically. So here what we used to do, we used to create floating static route, or in the case of PBR policy, okay, don't use this next stop, use this next stop. Route filtering we used to do, correct? All this we used to do manually. So here it offers application steering. Provisioning infrastructure. Provisioning infrastructure meaning you can provision means making it available. So you can have your storage in cloud. You can not only network, you can have the storage, you can have a service in cloud, you can have your network in cloud. So it gives you all kind of provisioning. Okay. Augmented automation. Augmentation means improvising. So we are not saying that SD-WAN introduced automation. Automation was already there. Now it has augmented it, enhanced the feature of automation. Security, okay. So SD-WAN offers high security. So it is very high security, high speed, highly reliable. Okay. Reduced my hardware cost. Okay. So cost, now understand, if all the storage is in my data center, so I have to build the servers, correct? It reduces your hardware cost, your cabling cost. So if you're building your data center is in one premises, okay, operation cost, you have to have ACs so that you can keep the servers chill. You have to maintain the electricity, correct? So if my data center is gone down, everything stops. So SD-WAN, you can push this entire data center in cloud. So no need of connectivity, no maintenance, no AC. It's in cloud only already. Right? It is cloud ready infrastructure. One of the best highlight of SD-WAN, it is cloud ready. Okay. So that is, we have not even touched SD-WAN yet. So we have just talked about what is SD network, what is SDN. Okay, so we have just spoken about SDN networks. So this is just an introduction. So tomorrow we will start with what is SD-WAN. Okay, so tomorrow actually we will be starting. So this was just an introduction of what is traditional, what is SDN. So yeah, I am done for the day. If you have any question, you can ask. I hope everyone has filled the form. So if not, kindly fill it. So this
Here,
is,
are we using still OSPF AHRP protocols here?
yes, OSP, or everything remains the same.
Then
So just, yes.
in the second point, provision networks quickly, right? Then everything remains same. Then how it will be quicker? These protocols, like even converging time and all same, right? Compared to traditional and then SD-WAN. How it will be quicker?
So here, let's say these are my two edges. Okay, far off location. We will talk about OMP later. OMP is a protocol that your vSmart uses. So that is what makes it quicker. So we will talk about all those things, don't worry. So how is it faster? Now let's say these are my two. This is, let's say this is in Bangalore. This is in Mumbai. Okay, both are connected with ISP. There is ISP in between. Okay. So now this is like, to answer this, you should know what is underlay and overlay. I have not talked about that. So I will talk about that in brief tomorrow. So just to give you an overview. So basic, okay. So here it's not that we will eradicate all this. So this is your underlay. Underlay traffic has to be there. So here, why is it quicker? So, okay, let me give an example of VPN. So in VPN, what do? We create tunnel, correct? So we create tunnel from here to here. But will this tunnel work if this is not there? It has to be there, correct? For the connectivity, this has to be there. So once you have the reachability from the ISP, then you create a tunnel and then you forward the traffic from here. It is similar. What your SD-WAN does is, so this complete tunnel, everything is also a part of your underlay. So over this, it creates its own tunnel, DTLS tunnel. Okay, so which is what makes it faster. So the packet is forwarded through this tunnel. It uses this virtual tunnels. So this will always be there. So there will be BGP, there will be OSPF, everything will be there. But the intelligence, the forwarding intelligence that it will be, the decision that it will be giving to your edges, V-edges, that is quicker, it is faster. OMP makes it faster. Okay, so wait, once we'll talk about all this, once we'll do the lab, you will get the clarity for that.
Ma'am,
Right?
I have a question. It's about lab access and how we will do this practical stuff. Can you please?
Yeah, so for labs, see, as I said, okay, so let me just give you a brief if you want to set up so as I said, the labs, you will get the lab access. Okay, you can access from you need to take the RDP, remote access of the server. Okay, but if you have Eve, okay, now EVE-NG, so we all know EVE-NG, it is a heavy software. So the RAM configuration, like, it is limited. So if you want to build your SD-WAN, if you want to build SD-WAN in your laptop, you would require minimum 64 GB minimum. Okay, because your vManage, this is one of the controller, it itself will take 16 GB. It itself, it will take 16 GB. So if you have 32, forget about it. It will lag a lot. Your vManage, it will take a lot of time to come up. Okay, so I will be using my laptop only. So you will see. Okay, now I'm not saying it will be slow. Okay, so I will be using my laptop. So I hope I got a good configuration, by the way. So I'm hoping it will work good. Okay, so you guys can access the server. So that is an option. But if you want to build up SD-WAN, okay, so I will be sharing all the images. Okay, I will upload all the images in the drive. So whenever in future, if you want to build up, so you can do that. Okay. So I will share all the SD-WAN images. Everything will be shared. You will get all the images. You will get all the serial, like there's a file. So everything will be shared. Everything will be available. Okay. If you need any assistance, you can speak to the lab trainer. They will assist you. Okay. Regarding the configuration, regarding the installation. Okay. Yes. So we have a different vManage, vSmart, vBond, vEdges. And there are different routers also. Yeah, Windows Server. So all this, if you have this much, you can build it in your laptop. Otherwise, lab is always available. Okay. Images, everything I will be sharing on the drive. So you can have the access to all of that. Lab access. So once we'll start, I will share everything in the WhatsApp. SD access, no, SD access is part of security. So Sushil sir. So once you have done with SD-WAN, you can join Sushil sir. So DNAC, he only takes care everything. All right. Any further questions, anyone?
No question, ma'am. Thanks.
All right. So I will see you guys tomorrow. I'm sure everyone has filled the form. So just ping me so that I can share the SD-WAN WhatsApp group link. Okay. Okay, then I'll see you guys tomorrow. Thank you, everyone.
Thanks, ma'am. Thanks for your time.
Thank you.